This is section 1.3b, linear equations. Two lines are parallel if they have the same slope. Alright, that's probably not new to you. If the lines have slopes m1 and m2, then the lines are parallel whenever m1 equals m2. Alright, that's basically just a complicated way of saying that two lines are parallel if they have the same slope. Okay, so if you have line 1 that has slope m1, you have line 2 that has slope m2, and m1 equals m2, then those lines are parallel. Example, the lines y equals 2x minus 3 and y equals 2x plus 4 have slopes m1 equals 2 and m2 equals 2. Therefore, these lines are parallel, and we can conclude that they're parallel just by seeing that the slopes are equal, and we can also verify that by graphing. Alright, so we graphed one line, y equals 2x minus 3, and that y-intercept is negative 3. And we graph the other line, y equals 2x plus 4, that y-intercept is 0, 4. Well, we can verify then graphically that these lines are parallel because they have the same slope. Two lines are perpendicular if one line's slope is the negative reciprocal of the others. If the lines have slopes m1 and m2, then the lines are perpendicular whenever m1 equals negative 1 over m2. Alright, so that's just writing the symbols that correspond to the first statement, negative reciprocal. So 1 over something is a reciprocal, and then you put a minus sign in front of that and you have the negative reciprocal. Here's an example. The lines y equals negative 1/2 x plus 1 and y equals 2x plus 4 have slopes m1 equals negative 1/2 and m2 equals 2. We can see that if you look at these as y equals mx plus b, you can clearly see that m1 and m2 have these values. So if we graph the two lines, first line 1, we see it there, has a y-intercept of 0, 1. Line 2, the red one, y-intercept 0, 4. These lines are perpendicular, and that means that their slopes are negative reciprocals of each other. Another example, find the slope-intercept form of the line that passes through the point 2, negative 1, and is A, parallel to 2x minus 3y equals 5, and B, perpendicular to 2x minus 3y equals 5. Alright, you should know enough to do this on your own, so pause the video, do it on your own, and when you have an answer for A and B, resume. And it's okay if you get stuck, because once you see the solution, it'll probably clarify what you need to do. Alright, this is just a matter of finding a parallel line and a perpendicular line. And what I would suggest is that your first step for both A and B should be to convert that standard form line into a slope-intercept form line. So pause the video, do that, and then resume when you're done. Okay, solution for part A. We want to find a line that's parallel to 2x minus 3y equals 5. So first step, as I had suggested before, is let's convert that general form line into a slope-intercept form line. So doing the algebra for that, y equals 2/3 x minus 5/3. We just got y by itself and ended up with 2/3 x minus 5/3. Alright, well, we know that a parallel line will have the same slope. Alright, a parallel line will have the same slope. And that's why I simply copied down the slope-intercept form, and I left the y-intercept as a variable because I know that parallel lines differ only in their y-intercept. Next step was simply to plug in the point 2, negative 1. So I plugged in negative 1 for y and 2 for x, and then solve for b. And you find that b is negative 7/3. So the final answer is y equals 2/3 x minus 7/3. that is a line in slope-intercept form that is parallel to the line 2x minus 3y equals 5. The solution now for part B. Again, it's the same line 2x minus 3y equals 5, and I do the same first step, converting that general form line into a slope-intercept form line. Okay, my next step is, since I know that perpendicular lines have slopes which are negative reciprocals of each other, I look at 2/3. I take the negative reciprocal of that, which is negative 3/2. And then I leave b as a variable because I know that the y-intercept will be different. Okay, so the next step then is simply to fill in the information that I know. I put -1 in for y, 2 in for x, and then I solve for b. b is 2. Therefore, the final answer is y equals negative 3/2 x plus 2. That is a line in slope-intercept form that is perpendicular to the line 2x minus 3y equals 5. Next example, the initial value of a motorcycle is $12,000. Its value at the end of 8 years is $2,000. What value will it have, A, after 5 years, B, after 9 years? Alright, again, you can do this on your own, but the general strategy is we can see that the motorcycle has gone down a certain total amount over 8 years. You want to find the amount that it goes down per year, and that'll be the key to solving this problem. So pause the video, do it on your own, and then resume when you have an answer. Alright, first we need to find the rate of change, or the slope. So the final value is 2,000, the initial value is 12,000, and you can consider those your y-coordinates, if you will. That would be your rise. And you can consider years as your x-coordinate, and that is your run. So if we are looking at this change in value as a slope, the rise over run is 2,000 minus 12,000, that's your rise, divided by 8, that's your run, and you get negative 1250. So that means that the value of the motorcycle goes down $1,250 each year. Alright, now since part A says after 5 years, then we simply plug in 5 for the time. And that is 12,000 plus 5 times negative 1250 equals 5750. So the total amount, or the value of this motorcycle that originally cost $12,000, its value after 5 years is $5,750. And by the way, that phenomenon of a vehicle or a car or any product going down in value over time is called depreciation. You probably have heard the term before, depreciation. Alright, and now the solution for B is simply using 9 instead of 5. And when you do that, you find that the value after 9 years of the motorcycle is $750, because it has gone down $1,250 per year for 9 years. Here's the classwork, page 35. Write these numbers down. Notice that next to number 107 I wrote final value equals 0. That's because that's information within problem 107 that the book doesn't give you. It just kind of assumes it. I'm just clarifying it there. In problem 107, the final value is 0. Alright, so write these problems down, and we'll see you in class.